I'm Mrs. Raposa, and I'm going to be going through with you your optimization notes that hopefully you picked up after your quiz during class. And just follow along on here, and when you're finished, you're going to scan it in and turn it in Schoology, what you have copied down. So all these problems are word problems, and we are going to be solving what's called an optimization problem. And we're going to have a quantity that needs to be optimized. We're going to find the optimal settings for this problem. You might be asked to maximize something. You might be asked to minimize something. It's just going to depend on the problem. So let's get started. Up top are some directions, but I'm going to jump right in. Problem 1. Find two positive numbers that the sum of the first and twice the second is 100. So let's go ahead and write that down. The sum of the first number, we don't know what it is, we can call it x, plus twice the second number, we'll call it y, equals 100. And then it says that the product is maximized. It's really important to decide what is being maximized or minimized. In this case, it's the product. So I'm going to write down a second equation. I don't know what the product is, so I'm going to call it P. And to find the product of the two numbers, I'm going to multiply x times y. This equation is what needs to be maximized. If you remember back to last unit, to find a maximum or a minimum, you have to take the derivative. So I need to be taking the derivative of this to find the maximum. I really don't like that there's two variables. So when I see two variables, I'm going to come over to this other equation and try to do some kind of substitution to rewrite my blue equation. So over here in this red equation, if I solve it for x, just subtract 2y from both sides. So 100 minus 2y. And then what I can do is take 100 minus 2y and substitute it in for x. So I'm going to rewrite this equation that needs to be optimized. P, which is product, equals 100 minus 2y times y. That equation already looks better to me because there's only y. I am going to distribute this y before I take the derivative. So P equals 100y minus 2y squared. Now think back to last unit. When you take a max or a min, you must take the derivative. So I'm going to take the derivative of this, P prime. My derivative is going to be 100 minus 4y. And to find a max or min, I am going to set this equal to 0. We always set it equal to 0. And just solve this for y. And I get y is equal to 25. Okay, so that means that my y value is 25. Now it told me I was supposed to maximize this. Really what we're supposed to do, but you can actually skip, is we're supposed to make sure that 25 is a maximum, like we did in the previous unit, where we would put it on a number line and we would test the derivative or the slope on either side of 25. And just as a reminder from last unit, we would take this test number and we'd plug it into the derivative in for y. And if I plug 0 in for y, 100 minus 0 is positive. And then I'm going to take 26 and plug it in for y. And if I do 100 minus 4 times 26, I get a negative number. And in fact, 25 is a max. But a little shortcut, if you only get one answer, you assume it's what they were asking for, which is a max. So one of my numbers over here is 25. To find my second number, I'm going to come back up to this red equation, and I'm going to plug in y being 25. And I get that my second number is going to be 50. Okay. Let's try number 2. Feel free to pause the video if you need to slow down or look at anything closer. So number 2 says the product of two positive numbers is 588. So I'll write that down. Product of two numbers, x times y, is 588. And then it says the sum of the first and 3 times the second is minimized. So it's a sum that's being minimized. So I'm going to write S for sum, because I don't know what the sum is. And the sum of the first number plus 3 times the second number is the quantity that needs to be minimized. So that's the equation I have to take the derivative of. I don't like that there's x's and y's in here, and so I'm going to go to this blue equation and I'm going to solve it for either x or y. Solving it for x is going to be more beneficial. So x equals 588 divided by y. And I'm just going to take that and I'm going to substitute it in for x right here. So my sum equals, I'm going to write it as 588 instead of over y. I'm going to put it as y to the negative 1. Same thing. Plus 3y. That's what we need to take the derivative of because that's what we're minimizing. So s prime, make sure you're using good notation, equals negative 588 y to the negative 2 plus 3. We're going to set it equal to 0. Have to solve it for y. Now at this point, I'm going to rewrite it. Negative 588 over y squared. I'll bring that 3 over to the right side. So equals negative 3. And then I just need to solve this algebra equation. Multiply both sides by y squared. Divide both sides by negative 3. And take the square root. And the square root of 196 is 14. Normally we would put plus or minus, but remember up top, it says we're dealing with positive numbers. So we're going to have that y equals 14. That's going to be one of my numbers. To find the second number, I'm going to go back to this blue equation. And in for y, I'm going to put 14. And 588 divided by 14 is 42. So my second number is going to be 42. Okay, at this point down here, when we found y is 14, we could have made a number line with it, and we would have seen that our problem is, our 14 is going to be a minimum, which is what we're looking for, but you don't have to. Okay, let's look at the next one, number 3. Says find the length and the width of a rectangle that has a perimeter of 200 feet and a maximum area. So if it's helpful to you, draw a rectangle. And this is my length. These are my widths. And it says that it has a perimeter of 200. Well, the perimeter is when you add up all the outside edges. So I have 2 L's plus 2 W's, and that's 200. And then it says that we're going to have a maximum area. So the equation I'm going to write down is that area equals, area is always length times width. So, and this is what we're going to maximize. I don't want to take the derivative right now because I have 2 variables over here next to each other. So I'm going to come to this equation that I have written, and I'm going to solve it for either L or W. One is not going to be more helpful than the other. I'll solve it for L. They're both going to be the same. Divide everything by 2. And I get that L is 100 minus W. I'm going to sub that in for L. And remember, I'm subbing it in because I don't want to take the derivative when it has L and W. I'm going to have to take the derivative, but I really want to simplify that first. So I'm going to distribute that W. Now I can take the derivative. So A prime, and I'm taking the derivative because this is what I want to maximize. 100 minus 2w, we'll set it equal to 0. Solve it for w. And hopefully you got that w equals 50. And we're trying to find the dimensions here. We're trying to find the length and the width. So let's go back and find the length. 100 minus 50. And the length is also 50. So my dimensions are 50 by 50. Okay. Problem number 4, we're actually going to skip this one. It's doable, but we're going to skip and move on to number 5. If you want a challenge on number 4, you're welcome to do number 4. The answer is 6 by 6 by 3. But we're going to skip that one together. You do not need to finish that one on your own. Okay, number 5 is a little bit different. Number 5 says, the profit in thousands of dollars for a company spending an amount of US dollars, S, in thousands of dollars on advertising is given by this equation. Find the amount of money the company should spend in order to yield a maximum profit. So the profit is the thing I need to maximize, and I have an equation for the profit. So let's just rewrite that equation for now. Profit is, and I'm just recopying this. That's what I want to maximize. And that means I need to take the derivative. Well, if you look, there's only one variable over here. So I don't need to worry about a second equation to sub in. I'm ready to go. I'm ready to take the derivative. So P prime equals negative 3/10 S squared plus 12S. Set it equal to 0. To solve this, I can factor an S out. Negative 3/10 S. Make sure your S doesn't look like a 5. Mine sometimes does. Plus 12 equals 0. And now since it's factored, I can set each factor to 0. I get S equals 0. That's not going to be my answer because the question asks how much money that the company should spend to get a maximum profit. Well, we're not going to pick spending $0. Let's solve the other factor, or set the other factor equal to 0. Multiply by the reciprocal. And when I solve this, I get S equals positive 40. So I got S equals positive 40. And the question asked, find the amount of money. Well, S was in thousands of dollars. So if I got S equals 40, then the company should spend $40,000. Okay, so that one did not require 2 separate equations, just one. All right, let's move to number 6. Number 6, this is a popular AP style question, number 6. The others show up, but I've seen this multiple times. And it says, determine the point on the line y equals 2x plus 3 so that the distance between the line and the point 1, 2 is a minimum. So what this means is I need to find a spot on this graph so that this distance is the shortest. So would it be down here? Would it be up here? Would it be straight out? Probably straight across, right? But we have to find what this point is. So what we're trying to find is the distance between 2 points. We're trying to find the distance between the point 1, 2 and the distance between 1, 2 and the other point that we're going to find, and that's what we're trying to minimize. We're trying to minimize that distance. So you have to remember the distance formula back from geometry. And you probably used it in pre-calc as well. But the distance between 2 points can be found by taking the square root of, and then we subtract our x coordinates. So x minus 1 squared. Plus, then we subtract our y coordinates. Y minus 2 squared. This is the equation that we're trying to minimize. That means this is the equation we need to take the derivative of. I really don't like that there are x's and y's in here, but I have something that we can use. We know that y is 2x plus 3. So let's go in, and before we take the derivative, let's substitute in. So x minus 1 squared remains the same, but now I have 2x plus 3 minus 2 squared. I really want to simplify this. Simplify it in as many or as little steps as you need. Second parentheses will become 2x plus 1 squared. I'm going to FOIL both sets of parentheses. I'm not going to write it twice, but in my head I'm going to imagine that I'm writing it twice. And I get x squared minus 2x plus 1 plus, if I FOIL my second set of parentheses, 4x squared plus 4x plus 1. I'm going to combine up all my like terms. And I have 5x squared plus 2x plus 2. That's what I need to minimize. So that's what I need to take the derivative of. There's this nice shortcut when you are minimizing. If you are minimizing or maximizing and you have a square root, you are allowed to drop it. Okay, I'm going to make a note of that on the side and then I'll explain why. So we're going to say when maximizing or minimizing, you can drop the square root before taking the derivative. Okay. Now, when we learned how to take the derivative of this, I'm going to erase this, but we previously would have to do this. We'd have to raise it to the 1/2 power, and then we'd have to do a chain rule to find the derivative. But with this new shortcut, I'm allowed to drop the square root, and I'm allowed to say distance, the derivative of the distance, or d prime. Pretend like the square root is not there. I get 10x plus 2. I promise you, if you did the chain rule and you worked it all out, you would get the same answer when you set this equal to 0. So x equals -2/10 or -1/5. So remember what we were finding. We were finding the spot on this graph that was closest. So far I found that my x coordinate is -1/5. So I can put that down here in my answer. My x coordinate is -1/5. To find my y coordinate, I can go back to this highlighted equation. Remember, the highlighted equation says y equals 2x plus 3. And now I know that x is -1/5. -2/5 plus 3. I'll think of 3. I'll think of 3 as 15/5. So 13/5. You could write 13/5 there, or if it's easier for you to think about 13/5 is 10. I'm sorry, 13/5 is 2. And 2/5 So that would work. 2 2/5. I take that back. It's 2 3/5. I'm sorry. 2 3/5. Might have just been easier to keep it at 13/5. But if you want to try to visualize it, our point is at -1/5 and then up 2 3/5 or 2 and a bit. And that would be the closest spot to that point on our graph. All right, I'm going to keep moving. Number 7. Number 7, there is actually a typo on your paper. Could you please change where it says minimum? Change that to maximum. Change minimum to maximum, and then let's give this a try. It says a rectangle is bounded by the x and the y axis and the graph of y equals 3 minus 1/2 x. What is the length and width? What length and width should the rectangle have so that its area is a maximum? All right, so we're back to the maximize minimizing. The area of the rectangle is what we're going to maximize. Let's change it to x times y, or let's write it as x times y. That would be the area of any rectangle, x times y. I don't like that there's two variables, but I have this equation. Y equals 3 minus 1/2 x. Let's sub it in. Distribute. And this right here is what we are trying to find the maximum of. Trying to find the maximum, so that's what we're going to take the derivative of. A prime. 3 minus, if I swing this to the front, they cross off and I just have x. Set it equal to 0 to find a max. And I get x equals 3. So my maximum rectangle would have a length of 3. So under my dimensions, I'm going to put 3 by. And then to figure out what my height or what my y value or length of this rectangle is, I'm just going to go into this equation that I know and say y equals 3 minus 1/2 times 3. Half of 3 is 1.5. 3 minus 1.5 is 1.5. So the dimensions of my rectangle should be 3 by 1.5. Okay, we're almost done. Let's go to number 8. This is our last one. Okay, number 8 says a rectangle ABCD with sides parallel to the coordinate axis is inscribed in the region enclosed by the graph of y equals -4x squared plus 4, as shown in the figure below. Find the x and y coordinates of the point C. So we're looking for this point right here. So when I write my points or my ordered pair here, it should be a positive x value and a positive y value, so that the area of the rectangle is a maximum. So the area of this rectangle is going to be maximized. Be careful when you find the area of this rectangle. This right here, we can call y. Start at the x-axis, go up. But this big piece right here, we have to decide what to call. Well, this part is x from here to here, because I start at the y-axis and I move over a distance of x. This part is also x. So I'm going to call that width of my rectangle there 2x. So if I'm trying to find the area, it would be length times width, or 2x y. That's what I'm trying to maximize. I don't like that there's two variables, but just like before, we're going to take y, we're going to put it in. 2x. And for y, we're going to put in -4x squared plus 4. That's what I'm trying to maximize. I'm going to distribute my 2x first. Now I'm ready to take the derivative a prime. Negative 24x squared plus 8. Set it to 0. X squared is 1/3. So x is going to be plus or minus 1/3. Which one should we use? The positive, because remember what we're finding is this point C over here. So we're going to say x coordinate is 1/3. My y coordinate, how are we going to find that y coordinate? We're going to take this equation, y equals negative 4x squared plus 4. And then for x, we're going to put in, oops, I forgot my square root, I realized. Please come back here. Your x needs to be the square root of 1/3. So here I'm going to put in the square root of 1/3. And then I'm going to try my best here to simplify this. Negative 4. The square root of 1/3 squared is just 1/3. Plus 4. Keep simplifying. This is negative 4/3. Think of 4 as 12/3. Same thing as 4. And then if I add these guys together, I get 8/3. So this point right here was we went over the square root of 1/3 and we went up 8/3. And that would be my answer. Okay, please scan in your work. It'd be best if you could put it all as one file. Scan in your work and upload it in Schoology to receive credit.